Hello, this video is for IXL Activity 8.C.7. It is titled Multiply and Divide Integers. By integers we mean positive and negative non-decimal numbers. And our 3-character code for this activity is Mike Delta Alpha. So this activity pretty much is focusing on your understanding of multiplying and dividing positive and negative numbers. It is a bit of a review on multiplication facts and division facts and your times tables and so forth, but the big thing that we're focused on here is understanding the multiplication of positive and negative numbers. So before we start, let's go ahead and have a little bit of reminder of that. So a positive number times a positive number is going to equal a positive number. And likewise, a negative number times a negative number equals a positive number. However, if you have a mix of negative and a positive together, you're going to get a different result. So if our first number is negative and we multiply that times a positive, that's going to give us a negative result. And likewise, if the first number is positive and the second number is negative, then we're still going to get a negative result. So there's a little bit of a rule that we could follow here. And that rule is that if they're both positive, then the answer is positive. If they're both negative, then the answer is positive. So if they're both the same sign, then it's positive. However, if they're opposite signs of one another, if one of them's positive and the other one's negative, then the answer is going to be negative as well. So let's go ahead and use that concept here as we work through this. So we have negative 30 divided by negative 5. So it's negative divided by negative. So the answer is going to be positive. I'm just going to put a plus sign. We don't have to enter plus there for whenever we type it in. I'm just putting it there as a reminder. Now I'm going to deal with 30 divided by 5. Well, I know that 6 times 5 is 30, so therefore 30 divided by 5 must be 6. On the next one, I have a negative times a positive. So they're different signs, so the answer is going to be negative. Now let's deal with the 9 times 7. 9 times 7, 63. We know that all the multiples of 9, that if you add the digits together, they equal 9, or at least a number divisible by 9, but up until we get above 9 times 11, etc. But 6 plus 3 equals 9. All right, 8 times negative 5. We have a positive times a negative, so our answer is going to be negative. 8 times 5 is 40. So we have negative 40. Here we have a positive times a negative, so our answer is going to be negative. Different signs. Now we got to deal with 19 times 11. I could do this a couple ways. I could do 19 times 11, stack them up and do the traditional algorithm here. Algorithm's a big fancy word we use to describe a process. So 1 times 9 is 9, 1 times 1 is 1, 1 times 1 is 9, 1 times 1 is 1. We can put a place holding 0 there if we like. Add these up, 9 and 0 is 9, 1 plus 9 is 10, carry the 1, and we end up with 209, negative 209. Now, I could have done this mentally. I could have thought of 11 as 10 plus 1. And 19 times 10 is just 19 with a 0 on the end, right? And 19 times 1 is 19. Then 190, and think of 19 as 10 plus 9. So 190 plus 10 is 200. Now, go ahead and add the 9 on there, and that would be 209. So if I were to do that mentally, that would have been my thought process. Let's go on to the next slide. Here we have a positive times a negative, so our answer is going to be negative. And here we have a 60 times 30. Well, let's just throw the zeros off for a moment. Let's think of 6 times 3. Well, that's 24. And then we get a 0 from each of them. Throw those 2 zeros back on, which technically we're doing 10 times 10 is 100, and 100 has 2 zeros in it. Here we have 176 divided by negative 176 divided by negative 22. Well, the rule works the same for division as well as multiplication. If they are the same sign, then the answer is positive. So this is going to be a positive answer. Now, on the next step is to actually deal with the numbers themselves. So 176 divided by 22. Now, let's do it the traditional way with this nice little long division thing here. Now it's being divided goes on the inside. The one doing the dividing is on the outside. 22 will not go into 17. but let's see, it will go into 176. I'm looking at it. Let's go back. 22 will not go into 1, so we have no number here. Now let's consider 17. In this case, it won't go into 17 either, so there's not going to be a number here as well. So now we have to consider this place value right here. It's going to be a single digit. And knowing this activity, since we're multiplying and dividing integers, chances are our answers are all going to be integers, that is to say non-decimal numbers. And plus, if it was a decimal number, many times the instructions for the question will tell you to round to a certain decimal place, or they might mention that to be sure to enter your answer as a decimal. But since they're not asking that, I'm going to guess that the answer is going to be an integer as well, non-decimal number. So let's see. Well, 2, if I just look at the 2 and compare it to 17, 2 will go into 17, 8 times? So let's go ahead and try 8. It might be too much. If it is, we'll back off 1. So let's try 8. 8 times 2 is 16. Now this is probably it because this column matched up. Carry the 1. 8 times 2 is 16 plus the 1 is 17. Indeed, I have 176. So the answer is 8, and that's a positive 8. Remember that? Looking at the next slide, we have a negative divided by a negative, so this is going to be positive. And 198 divided by 3, so let's do 198, and let's divide that by 3. 3 will not go into 1, so no number is going to go here. 3 will go into 19, 6 times for 18? All right, subtract those, we get 1. And bring down the 8, and the 3 will go in 18 again 6 times, and that's going to equal 18. Leave us with 0, so our answer is 66. Over here we have 91 divided by 13, because remember, every fraction is a division problem, so this is 91 divided by 13. Well, let's see, how could I do this? I could just do guess and check. 10 would be too many, right? And plus, that's not going to work. 9's, let me see, 10 of them would be 130. I'm going to try right about 7, right in there. Plus, notice 7 times 3 is 21, and notice this 1 here. So 7 times 3 is 21. Carry the 2, and 7 times 1 is 7, plus 2 is 9, and sure enough, we end up at 0. And that is a positive divided by a positive. So the signs are the same, so the answer is positive. Here we have 58 times negative 15. So it is a positive times a negative, so our answer is going to be negative. Now let's deal with that 58 times 15. So 58 times 15. And, yeah, I could. I'll go ahead and do it this way. I'm thinking of another way of doing it, but we'll go ahead and do this. So 5 times 8 is 40. Carry the 4. And 5 times 5 is 25, plus 4 is 29. And 1 times 8 is 8, and 1 times 5 is 5. Add these together, right? So we get 0, bring down that 0. 9 and 8 is 17, carry the 1. And 5 and 2 is 7, plus 1 more is 8, 870. All right, last question here. Negative divided by a negative, so they are the same signs. So the answer is going to be positive, so I want to keep that in mind. Now the next question is, how do I want to do this? I could go ahead and do 1,130, back. Hold on. 1,134, and I could divide that by 42 and approach it that way. But I think I want to do something different on this one. And I might even kind of show this. I might be able to mental math this, but I want to show you what's going on in my head. So I'm thinking I gotta multiply 42 times some number to get to 1,034. So because whatever number I find is going to be the answers. If I multiply whatever the answer, if I multiply it times 42, I'm going to get this number here. So let's try this. Let's consider 42. Not 40, but 42. Now if I multiplied that times 10, right? I multiply it times 10, I'm going to get 420. That means if I multiplied 42 times 20, which is twice as much as 10, I could just double this and get 840, right? I can double those in my mind. So I'm thinking, okay, I'm up to 840. Now if I added another 420, I know that 8 plus 4 is 12. It's going to be too much. So let's go ahead and do this. Let's just account for 20 of those 42s and go with 840. Let's do 1134 minus 840. Do the subtraction. 4 I need to borrow one here, right? 13 minus 4 is 9, right? And then I borrowed one, so this is 10 minus 8, that's 2. So whenever I subtract that 840 from the 1134, I end up with 294. Now let's think of that 42 again. Well, if I did 10 of them, that would be 420. That would be too much, right? So what if I tried, let's say, maybe 5 of them? Would that work? Let's try that. 42 times, well, wait a second. If 42 times 10 equals 420, then 42 times 5 must be half of that, because 5 is half of 10. So that must be, what, 210, which is less than 294. So let's go and do that. So I got 20 of them already. I'm doing another 5 of them, and that gave me 210. Let's subtract that. 4 and 42, or 9 minus 1 is 8, and 2 minus 2 is 0. So now I'm down to 84. How many times will 42 go into 84? Twice, right? 2 more times. So I did 20 times here to get 840. Subtracted that, left with 294. I did 5 of them, which was 210, which left me at 84. 2 more 42, so now 20 plus 5 plus 2 is 27. And if you want, you could grab your calculator and check that out. 1134 divided by 42. Hit enter. It should give you 27. And I'm going to guess a lot of people probably use a calculator on many of these. Anyway, if you do use a calculator, remember that the negative sign on a calculator is different than the minus sign. So if you try to type in negative 1134 divided by negative 42, be sure that you are pushing the negative button instead of the minus button. Most times you'll find the negative button down at the bottom next to the 0 or the decimal number right in that area. All right, so that is everything I have for IXL 8.C.7, multiply and divide integers. Good luck with your activity.